this is the next lesson on vector equation. Today we're going to discuss if two vectors are parallel to each other or if they intersect each other or if they intersect each other or if they are neither parallel nor intersecting. There's another case as well. 2D mein there are two cases. Either two lines are parallel or two lines are intersecting. But in 3D, there's another case where two lines are not parallel and not even intersecting. That is called skew. Let me try to explain it. Let's say this is a room. This is a 3-dimensional room. This is your classroom, let's say. So it's roughly in the shape of a cuboid. So let's say you hang a rope from here to here, and then you hang another rope almost near to the bottom of the floor and from this face to the opposite face. So these two ropes are not parallel to each other and they don't intersect either. So this is the third case where two vector equations are neither parallel not intersecting. This is called skew. This is intersection and this is parallel. So again, in 3-dimensional case, either the vectors are parallel to each other or the vectors are intersecting or the vectors are skew, neither intersecting nor parallel. Okay, now it's easiest to tell when two vectors are parallel. Let's say there's a vector, parallel vectors. A parallel vector, let's say this is one of the vector r is equals to 1, 2, 3 plus lambda, let's say -1, 0, and 3. And here's another vector, r is equals to 3, 2, 1 plus mu, and then this is -2, 0, and 6. Now, if you're asked to state if these two vectors equations are parallel or not, or if these two vectors are parallel or not, all you have to look at is the direction vector. This is called the direction vector and this is called the direction vector. And now treat it as a normal case of two-column vectors. How do we tell if these two vectors are parallel or not? They must be scalar multiple of each other, and we can see that they are. If you multiply 2 with the first equation's direction vector, you get the second equation direction vector. So hence they are parallel. Hence vectors are parallel. Right? Because remember from the equation r is equals to a plus tb, t or let's call it mu p. This is actually a vector parallel to the other vector. So let's say this is a vector, then that vector b would be parallel to this vector. Similarly, let's say this is the second vector, this one. This one, sorry. The second equation that I wrote. Okay, this is the other vector. And then this is the b for that vector. So notice that if these two are parallel, then their direction vectors are also parallel. So all you do is look at the direction vector. You don't have to look at the entire vector. If two vectors are parallel to each other, that means their respective direction vectors are also parallel to each other. So hence you only look at the direction vector in case of parallel vectors. Okay, so that's the case of parallel vectors. Take a look at intersecting vectors, the skew effect.
मैम वैसे ए लेवल का रिजल्ट कब आता है, 10th को या 11th को अगस्त?
मेरे ख्याल में 10th नहीं,
पिछले साल तो 11th था, मेरे ख्याल से अब 10th है।
मुझे तो लगता है 10th है, maybe I'm wrong. A2 वालों का तो और लेट है क्योंकि उन्होंने एक पेपर काफी देर से दिया. Anyway,
यस
अच्छा
मैम।
now let's talk about intersecting vectors or skew vectors. Intersecting, intersecting or skew vectors. So the question is, find if the given vectors are parallel, intersecting, or skewed. So the vector equations are R equals 131 plus m times minus 212 and R equals 0 minus 28 plus n times 1 minus 1 1. So first thing we determine is if the two vectors are parallel or not. So all you have to do is see if these two are scalar multiple of each other. They are not, so hence they are not parallel. So you write since k times minus 2, 1, 2 is not equals to 1 minus 1, 1, hence not parallel. That is the first thing you should check. Okay, now we check if these vectors are intersecting or are they skewed. So for that, what you do, you equate the two equations. You try to solve these simultaneously. So I'm writing, this was the check for parallel lines. Parallel vectors, now we're doing the working to check for intersecting lines. So I'm going to equate the two and try to solve it simultaneously. Acha, Heather, are you doing it with me? Yeah, are you just looking at my working? How are you going about it? Because I want you
जी
to
मैम।
keep a strict look at my working. If I make a mistake, you're supposed to tell me right away. So that's the first equation. Then it's 3 plus m equals minus 2 minus n. Second equation. Third equation, 1 plus 2m equals 8 plus n. So solve these two simultaneously and find the values of m and n. We're going to do that here. It's going to be 1 minus 2m equals n. Substituted in the second equation, 3 plus m equals minus 2 minus 1 minus 2m. That is 3 plus m equals minus 2 minus 1 plus 2m. M equals 6. Is that what you got as well, Heather?
यस मैम, मेरा भी यही आ रहा है।
Take it. M is 6. Now let's find n. N would be 1 minus 2 times 6, so that is minus 11. Okay. Now, if m is 6, n is minus 11, let's substitute the values of m and n here and see whether we get the same coordinates on both sides. If we get the same coordinates on both sides, that means yes, the two vectors intersect. And if we don't, then that means the vectors are skewed. So let's say we have 1, 3, 1 plus 6 times minus 2, 1, 2. And is that equals to 0, minus 2, 8 plus minus 11, in fact, minus 11 times 1 minus 1. So we have minus 11 here. Then we have 9 here. And then we have 12 plus 1, 13 here. And then we have minus 11, 9, and minus 3. So since value of m and n do not satisfy all three coordinates, or since all three coordinates are not equal, hence the lines are not intersecting but skewed. Since all three coordinates are not the same, hence skewed. Parallel हम पहले ही check कर चुके हैं. Must first check parallel, then check if they intersect, and if they don't intersect, you write a final concluding statement and say so it's skewed. Okay, another example like this. Find whether if the following vectors are parallel, intersecting, or skewed. So R equals 131 plus M minus 2 minus 1, 2. And R equals 0 minus 2, 8 plus N 1 minus 1, 1. Okay. First thing, isn't it the same?
हमें पहले नहीं किया था सवाल.
हाँ, वही कर लिया मैंने. 0 नहीं, एक value slightly different. This one value is different. This will probably be intersecting. क्योंकि खाली एक value का difference है. I think this was 1 in the previous question. Anyway, now first we can tell that they're clearly not parallel because these two direction vectors are not scalar vectors of each other. So since k times minus 2 minus 1, 2 is not equals to 1 minus 1, 1, so not parallel. Now let's check if they intersect or not. For that, you solve these simultaneously. So 1 minus 2m, 3 minus m, 1 plus 2m equals n minus 2 minus n and 8 plus n. Okay. So we have 1 minus 2m equals n. Now in the second equation, I'm going to replace n with that. Minus 2 minus 1 minus 2m, which gives 3 minus m equals minus 2 minus 1 plus 2m. So we get an m here and a 6 here. M is still 6. अच्छा एक और भी डिफरेंस है इसमें
M3 आ रहा है मेरा, तो 2 आ रहा है M।
2 आना चाहिए मेरा क्यों नहीं आ रहा 1
M2
प्लस
आ रहा है मेरा, N-3 आ रहा है।
बिल्कुल सही आ रहा 1 3 1 minus 2 minus 1 2 1 minus 2 is equals to m 3 minus m equals minus 1 plus 2m 3. Yeah. Must have made a mistake somewhere. Let me just try to find it. Okay. Here's the mistake, like pointed out by Heather, that when this m goes to the other yes. When this m goes to the other side, it becomes 3m and we get 6. So 2 is equals to m, right? And when m is 2, then 1 minus 2 times 2 would be equals to n. So n is minus 3. Yes, m is minus 3. Okay, now let's substitute m and n here and let's see if we get the same values on both sides. So 1 minus 2 times 2 is minus 3. And we have minus 3 here as well because n is minus 3. Now 3 minus m would be 1. And minus 2 minus 3 would be 1 as well. Okay. And the last one, 1 plus 2m. So that would be 5. And 8 plus n is 5 as well. So since all three coordinates are the same on both sides, hence the vectors intersect. Since all three coordinates are equal, hence vectors intersect. And in many questions, they also ask for the point of intersection. So you write at the point minus 3, 1, 5. Many questions they say that if the vectors intersect, find the point of intersection. Now we're going to discuss how to tell if two vectors, no, how to find angle between two vectors. It's very easy. Angle between two vectors. Okay. अच्छा ये देखो. Here's a vector. And then from R is equals to A plus TB. This B is a vector parallel to the other vector. So let's say B is this, right? And now I'm going to draw another vector, let's say this. And the vector parallel to this is this vector. So notice that whatever is the angle between the original two vectors, the pink vector and the blue vector, you'll get the same angle between the parallel vectors to the original vector. Or in other words, you will get the same angle between the direction vectors. Whatever is the angle between the two vectors, you will get the same angle between their direction vectors. So all you have to do is find the angle between the two direction vectors. So the question is, find the angle between r equals 1, 2, 3 plus t 2 minus 1, 2 and r equals minus 2, 1, 5 plus m 3, 2 minus 5. So this is the direction vector of the first one, and this is the direction vector of the other one, and we will find the angle between these two using the dot product method. So cos theta would be 2 minus 1, 2 dot 3, 2 minus 5 upon magnitude of both. 2 square plus 1 square plus 2 square times 3 square times, plus 2 square plus 5 square. Cos theta equals 6 minus 2 minus 10 upon square root 2 square plus 1 square plus 2 square is 9, which becomes 3. So we have a 3 here. And 3 square plus 2 square plus 5 square, which is under root 38. Okay. So the numerator would be minus 6. And now you find cos inverse of this. Minus 6 upon 3 under root 30. Since cos is negative, that means it's going to be an obtuse angle. Just a quick revision of the old concept. So I'm getting 108.93. 108.9 correct to 1 decimal place. First, you're going
मैम
to
ये
write
कैसे पता चलेगा कि ये वेक्टर्स डाइवर्ज हो रहे हैं एक पॉइंट से?
वेक्टर्स डाइवर्ज हो रहे हैं इनके बीच में, अब
मतलब
तो
कि
स्क्यू
अवे
केस
जा
में
रहे हैं, मतलब कि टुवर्ड्स
intersect
नहीं
कर
आ
रहे
रहे
हैं।
हैं।
हाँ, इंटरसेक्ट कर रहे हैं, ये कह रहे हैं। क्वेश्चन तभी पूछेंगे, एंगल तभी पूछेंगे जब इंटरसेक्टिंग वेक्टर्स होंगे, वरना आप डॉट जब कॉस इनवर्स करोगे तो मैथ एरर आएगा if they're not intersecting vectors. All right,
ठीक है मैम।
that would mean either they're parallel or they're skew. All right. Lastly, now we will discuss how to find perpendicular distance from a point and a vector to the vector. So here's a vector. And let's say here's a point. We will learn to find the perpendicular distance between a point and a vector. So the last subtopic of vector equation is perpendicular distance between a point and a vector. So the question is, find the perpendicular distance between a point A 1, 1, 4 and the line R equals I minus 2j plus k plus t times minus 2I plus j plus 2k. So let's use the same figure. There's a point A with coordinates 1, 1, 4. And there's a vector equation which has equation 1 minus 2, 1 plus t times minus 2, 1, 2. Let me just quickly confirm if I copy the same values. Yes, looks like. Okay. Now the question is to somehow find this position vector, this distance, sorry. We have to find this distance. So first, what I'm going to do is I'm going to say that this point of intersection here is, let's say, X. This is point X. Right. This is not X, don't get confused by that. That's just a point. Okay, so that point of intersection between the perpendicular distance, between the perpendicular line and the vector is X, let's say. So then that means that OX vector can be expressed like this. 1, 2, minus 1 plus t minus 2, 1, 2. This R is actually OR. Remember, you said that R is also a position vector. So yes. So if OR is this, then OX will also satisfy the same equation because X is lying on the same line. So that is what we know about OX. And what do we know about OA? We know about OA that is 1, 1, 4, or in other words, I plus j plus 4k. Okay. Now, what you need to do is find the vector AX. So AX would be OX minus OA. Heather, are you there?
Yes.
किधर तक बात सुनिए?
मैम ये वेक्टर ओआर वगैरह था.
Okay. Vector OR, OX और OA नहीं सुना?
मैम सुना था.
अच्छा ठीक है. So you can find the expression for OX. The expression for OX is the same as the vector equation because X lies on the same vector. Okay. And then OA obviously is 1, 1, and 4 written as the form of column vector, or can also be written as OA equals I plus J plus 4K. Okay. So now we can find the vector AX from OX minus OA. So that would be 1
मैम
minus
बस ये ओएक्स इक्वल टू ओआर क्यों है, ये समझ नहीं आई मुझे.
t की वैल्यू डिफर करेगी. For OR and for OX, t will be different. ठीक है? It's not going to be the same value of t. For a particular point, t is same. But if you keep moving on a vector line, t change hota jata hai, and that's how you get the coordinate. Do you understand that now? But the general equation is going to be the same. All right?
तो फिर मैम ये जो पहला होता है, मतलब कि वेक्टर जो इंटरसेक्ट कर रहा होता है लाइन के साथ, जो लाइन के ऊपर होता है वेक्टर,
हाँ.
ये कैसे सेम हो गया ओ एक्स और ओ आर का? ये डिफरेंट नहीं होना चाहिए?
क्योंकि जब पॉइंट इंटरसेक्ट कर रहा है तो उसमें तो सेम पॉइंट है ना, तो टी की ए की वैल्यू लेनी होती है. ठीक है. बट if there are multiple points on a vector line, let me draw a vector line. ठीक है. अब इसकी इक्वेशन तो वही है, same equation as this. However, this point will have a different value of t, this point will have a different value of t, this point will have a different value of t, and this point will have a different value of t. However, if I say that these two vectors intersect, and this is the point of intersection. So when we're finding a value of a point of intersection, then that is one particular point. तो उसके लिए हम constant m लेते हैं या constant t लेते हैं, जैसे हमने पिछले क्वेश्चन में किया. ठीक है? So expression for OR and expression for OX is going to be exactly the same. They will have two different t's. ठीक है? Anyway, अच्छा जी, back to this. So 1 minus 2t and 2 plus t and minus 1 plus 2t. Minus 114. So that would be 1 minus 2t minus 1 is just minus 2t. Then 2 plus t minus 1 is 1 plus t. And minus 1 plus 2t minus 4 would be minus 5 plus 2t. And that is the expression for vector AX. Okay, so now I have the vector AX. Which is given. Okay. What is going to be the relationship between AX and OX?
डॉट प्रोडक्ट जीरो हो जाएगा.
Exactly, dot product zero हो जाएगा. अब देखो OX में भी T की form है. OX is also in the form of T and AX is also in the form of T. So what we'll do instead, to avoid that, we can only take this direction vector. इसका ये direction vector है. So that means dot product of this direction vector and AX will also be zero. If I extend AX, so this will also be a perpendicular line. थोड़ा खराब हो गई line, but if you stretch that line downwards, you will still have a perpendicular relationship between the direction vector of OX and the original AX. So what I'll do now is write the dot product of AX, which is minus 2t, 1 plus t, minus 5 plus 2t, dot the direction vector of the original vector minus 2, 1, 2, and this should be equals to 0. So let's see. We have minus, बल्कि plus 4t plus 1 plus t minus 10 plus 4t equals 0. So we have 9t equals 9. So we have t is equals to 1. Did you get the same?
Yes, ma'am.
Up t is 1. So when t is 1, we're talking about this foot here. Either t1. Okay, not on any other points. ये ax जो exactly coordinate है उसका t1. Okay. So t is 1. So that means now we can find the vector ax and take its magnitude. Ax was what? Minus 2t, 1 plus t, and minus 5 plus 2t. We're going to substitute the value of t here and then take the magnitude. So that's going to be minus 2, 2, and minus 3. And then the magnitude of this is going to be 2 square plus 2 square plus 3 square. Under root 17. I think I made a mistake. That was not the answer. Answer should be 3 minus 2t. So I copied the question wrong. Here it was correct. It was minus 2j, but I wrote 2j here, but the method is correct and the answer is correct. This answer is correct for the equation I wrote here for OX. So never mind the mistake. Another question like this, which is, this would be the last question for today. So again, the same question, find the perpendicular distance between perpendicular distance is missing. Find perpendicular distance between point 1 minus 6 and minus 1. And the line R equals I plus 7j plus minus k plus t times 3i 12j and minus 4. I plus 7j minus k plus t times 3, 12 minus 4. All right. So for me, drawing the figure helps. Here's the vector whose vector equation is R equals 1, 7 minus 1 plus t times 3, 12 minus 4. And the point A is 1 minus 6 minus 1. Right. So I'm calling this point here X. I'm going to start with that OX will have the same equation as the vector equation 1, 7 minus 1 plus 3t here plus 12t here minus 1 minus 4t. 1 plus 3t, 7 plus 12t, and minus 1 minus 4. Okay, that is OX. Now OA is 1 minus 6 minus 1. So AX is going to be OX minus OA. Let's just do it in one step. That would be 3t. That would be 1 plus 12t. And that would be 0 minus 4. Let me confirm. 3t, 1 plus 12t minus 4. 13 likha hua hai. Yes, it's going to be 13. 7 minus 6 nahi hai. 7 minus 6. So that's going to be 13. So this here is 13. 13 plus 12t and minus 4. All right, so that's AX. Now we know that the dot product between AX and this direction vector is going to be 0. So 3t, then 13 plus 12t, then minus 4t, dot 3, 12 minus 4 will be equals to 0. Okay, so that's going to be 90 plus, what is 13 times 12? 156 plus 12 into 12, 140 plus 16 equals 0. So 144 plus 16 plus 9 is 169. That is a very weird value. 30, 169 equals minus 156, and t is, there's a t here as well. T is minus 156 divided by 169. Minus 12 by 13. That is the correct answer. 40. Okay. So now what we'll do is substitute the value of t in ax and then find its magnitude. So ax will be okay, I'm going to substitute minus 12 by 3 there. So 3 times minus 12 by 3 would be just minus 12. Then 13 plus 12 times minus 12 by 3 would be minus 35. And minus 4
-12/13 नहीं था वैसे।
देख लेते हो, और ये लास्ट वाला 16 minus 35 कह रहे हो, गलत है। हाँ
मैं कह रहा हूँ कि टी गलत है आपका, -12/13 नहीं होना चाहिए।
हाँ, minus 12 by 13, sorry, minus 156 divided by 169 is 12 by 13, yes, sorry. So these would be different then. Okay, so 3 times minus 12 by 13 is minus 36 by 13. Then 13 plus 12 times minus 12 by 13 is 25 by 13. And lastly, minus 4 times 12 by 13, minus 4 times (48 by 30). Did you get the same values with it?
Yes, ma'am.
Okay. And then we find the magnitude, which will be square root of and squares of all of these. Square of 36 by 13 plus square of 25 by 13 plus square of 48 by 13, which gives the answer at the end is 5. Did we get 5? Heather confirm करना।
Yes, ma'am.
5 ही आ रहा है।
Yes, ma'am.
ओके ठीक है. अच्छा, एक और चीज भी इन क्वेश्चन पे पूछ लेते हैं. दे मे आस्क फॉर द point of intersection of the foot of perpendicular and the vector, this red point. Again, let me repeat that. In the end, they might also ask for the coordinate of foot of for the coordinate of the foot of the perpendicular. Yes. So iska you'll have to first state the coordinates of x. So that's not going to be a problem because you already have ox. This is ox, and you just have to substitute the value of t in ox, and you'll get the coordinates of x as well. All right, so let's do that as well. So coordinates of x would be uh, coordinates of foot of perpendicular. So from here, perpendicular. Okay, so from here, you substitute the value of t. Can you tell me what you get? Turning off the video because my internet connection is unstable. Can you hear me, Heather? Heather, can you hear me?
Yes, ma'am.
Okay. जिसमें t की वैल्यू सब्स्टिट्यूट करके बताओ इन ओ है. I'm copying the answer from the book. I hope you get the same value. Please confirm. First one is minus 23 by 13. Next is minus 53 by 13. And the next one is minus 61 by 13. Do you get this, Heather?
Yes, सही आ रहा है मेरा.
Okay. Then you write it in the form of coordinates. Since you were asked to find the coordinates of the point of intersection, so your final answer must be like this, right? See you in the next class tomorrow, inshallah. Allah Hafiz.
Okay, love, ma'am.